Hello everyone. Today I'm going to discuss about some software development design principles that will really help us in our software development purpose. So basically in this slide I'm going to discuss about some problem statement and the solution that is provided by those software design principles. Okay? So let's start. So the first problem statement is if you write the same code repeatedly, or let's say you write the same code repeatedly at different places, so why this is a problem? Because if you write the same code repeatedly, then it may cost your time and effort. Basically, there is no meaning to write the same code repeatedly. So, which design principle strictly told us, please don't do it. So that is like the dry principle. So dry principle basically it means don't repeat yourself. So the solution is if you write some code, please keep in mind you need to reuse this code. Okay, and also you need to follow a proper or good naming conventions for your like writing method or variable or class or objects. So why this good naming convention is necessary for us? Let's say you write a method and after 2 year or 3 years later or 1 years later or 6 months later a new member is joining in your team, and this new member asked you about your writing method. But I think if you don't follow a proper naming convention, then really it's difficult for you to remember why you writing this method. So I think it's really necessary for us to provide a good naming convention so that you can easily understand after a later period of time. And also we need to write code in a appropriate layers, location and services. So that's it for the dry principle. Now the second problem statement is if we write code very complex way, or if we write a code that is more difficult to modify at any later point of time, then I think it's a huge problem for us. Like I mentioned a quotation, like if you can't explain it, you don't, I think it means you don't understand it well enough. If you understand it well enough, definitely you will able to explain this code. So I think this is very true, very true. So the principle provides the solution for us, that is like the KISS principle. So this KISS principle basically focused on the simplicity of your code. This KISS principle told us please make this code as much as simple. Okay, so how we achieve that? So when we writing any code, we need to, like, we don't need to be hurry. I think we need to make a pause, then we need to think in a proper way, like what is the best solution, what is the simplest solution, what is the what is the easiest solution. So this type of things I think we need to keep in our mind when writing any kind of code. So if I summarize this principle, basically this principle focused on the simplicity. So we need to keep in mind when we writing any kind of code. Now the third problem statement is let's say we implement so many things, but all the things is really don't need. So I think this is a problem, because if we really write like the unnecessary things, I think this is there is no meaning to write unnecessary things that is really don't need. Because it consume the cost, time and effort. Let's say if you import like get method, post method, retrieve and delete method from other from some other files or some other component, but you only use the get method in your file. So I think there is no meaning to import this post, retrieve and delete method. So the problem that we the thing that we when we writing the code, basically we think maybe this post method is uh, required in future, maybe this retrieve method is required in future, but maybe this retrieve or post method never ever required in future. So I think this is really meaningless to write something that is really don't right now. So the principle that is strictly told us, please don't write something that is really needed. So that is like the Yagni principle. So the meaning of Yagni is you aren't gonna need it. So that means don't really do something until you really find value in doing it. Or if it won't come handy later, don't do it now. Now the fourth one is like the solid principle. So the this solid design principle basically the combination of these five design principle. One is SRP, that is single responsibility principle. Another is open closed principle. Another is Liskop substitution principle. Fourth one is interface segregation principle, and the fifth one is dependency inversion. So let's go on by one. The single responsibility principle. So what does it mean? So it means like when we write a method or class or function, and it does so many things or it does so many responsibilities, so I think it's a problem. So why it's a problem? Because if you write so many things in a method or in a class, like let's say when a programmer comes to change it, then he has to make sure that these changes do not break other things, as lots of things is doing in this method. So this is like the programmer needs to take care some extra effort, like needs to think some extra things, like not break the other things of his changes. So the single responsibility principle basically focused on like code should be focused, narrow, and does one thing and only one thing well, and it has only one and only one reason to change, so the changes may not affect the other things. So and also like if you follow this single responsibility principle, then the cost of changing that code is much easier. Now the second one is open cross principle. Let's say a piece of code. So basically, this open clause principle means like the piece of code, it can be classes, method, or component, should be open for extension and closed for modification. So what does it mean? Like you write a method, or you write a class, or you write a component, and in a later period of time you need to update that component, or you need to update that method. So this open clause principle strictly told us don't update the existing code, like the existing code in that component, but you may add or you may extend that component by adding some new things or new features. So these things basically focused on this open close principle. Now the third one is like the Liskop substitution principle. So that this principle basically focused on, let's say you have a derived class and you have a base class. So the derived class or the child class able to use the instance of the base class or the parent class, but the child class or the derived class don't need to understand the base class or the parent class, or the derived class don't need to know the complete things in the base class. The derived class easily use the instance of the base class. So this is the things that focused on this LSP principle. Now the fourth one is like the interface segregation principle. So this principle basically focused on uh, it's kind of like the similar thing like the single responsibility principle. Let's say I think it can be happen like the client should not be forced to implement an interface if they don't need it, right? Client should not be forced to implement an interface if they don't need it. When an interface contains more than one function and client needs only one but not all, so in this case, client is forced to implement all functionality of the interface. So I think it's a bullshit decision in this scenario, because clients only need one function. So why the other functions you need to implement? So the best solution is you need to keep interface cohesive and narrow and focused only one thing. Okay, so in that case you don't need to like implement the other function that clients really don't need. So this is the ISP principle. And the last one is dependency injection. So what does it mean? It means it means like the coupling. So what is coupling? Let's say you write a piece of code and it depends on another piece of code. So this is called the coupling. Okay. Or you may call it like the dependency. Like this piece of code is dependent on another piece of code. So the best way to minimize this dependency, or the if I said like the best case is to remove the dependency, but if you are not able to remove the dependency, then please minimize the dependency. Otherwise, like if you change the dependent piece of code, then there is very much possibility to hamper the dependent another piece of code. So I think we need to remove the dependency when during our development time. So, like if you can't remove all dependency, then at least minimize it. So that is called loose coupling. Or if you can't remove the dependency, also not able to minimize this, I think this is called the tight coupling. So we need to focus on the loose coupling, I think. So this is all about the software design principle, and I think it will really help us if we follow these design principles in our software development time. So thank you. I think you will like enjoy this video, and let's see you in your my next video.